Hello YouTube, this is umills03. So there have now been 3 lessons released on functions. Remember from lessons 13 through 15, we talked about functions in Python, and we've been basically clarifying some of the fundamentals. We basically talked about the difference between functions that print quantities and values and functions that return quantities or values, right? And we said that a function in the previous video, we said that a function could be capable of doing both of those things, right? So if you take a look at b equals new function of 10 and 4, it calls the new function, right? And as a result of doing that, and by calling this function, we go ahead and run these 2 lines of code. So indeed, just by setting b equal to new function of 10 and 4, you print 10 times 4, so you print 40, but then b is assigned to 10 minus 4, right? So the output of new function is 6, okay? But one of the things that new function does while it's running is print 40. So hopefully you can understand the distinction there, okay? And so hopefully, and then we were also talking about data types, remember? And you have to remember that data types are kind of arbitrary in Python. It's not like Java where you specify that a function is going to accept an int and then a double and then a Boolean, right? In Python, it would just be X, Y, Z, okay? And it basically gives you a little bit more flexibility. And, you know, the fact that you don't have to declare those things manually is kind of nice. The only thing that you have to be careful about is just to make sure that the data type that you're bringing into the function makes sense within the context of the function. So if it's going to be iterating through elements in W, then that input W needs to be a list, okay? Or another data structure. We're going to be talking about other types of iterables in an upcoming lesson. We also said the function can be an input to a function, right? And we saw examples of this where basically we were literally passing in a particular function as an input to a function. Okay, and then you can go ahead and deal with that and you can make different types of calls. So it's sort of intuitive. It's not that hard to see, but it's just nice to be able to, it's nice to know that you're able to do that, okay? And then we also talked about how you don't have to use all the inputs to a function and how a function might not even have any inputs at all. So I don't know if we said this earlier, but what if you said define h or something, okay? And here we have empty parentheses, okay? So a function that has empty parentheses next to it does not accept any inputs, okay? So basically you could just go ahead and return a value here. Okay, so now if you say print h, you know, times h, what would this print? So now if you go ahead and run it, we should see the 100, right? And I've been doing other examples, so let's just keep up with this number on the bottom here. So it would be 100, right? And so that's why you see the 100 there, because 10 times 10. Okay, and then we were also talking about Java docs, right? And I guess before we go into that, we also said that you can have a variable that literally refers to the value that a function would return. So you already have a function called another example, and you defined it here. But then you create a variable, and you set the value of that variable equal to the result of the another example function, okay? And so basically, if you call referral of 10 and 2, basically it says, well, what's referral? Referral is just another example. So I'm going to run another example with these exact inputs. So hopefully that's clear to you with what's going on with that. And then the last thing that we said basically is that we could think about Java docs, right? And so we have this formal documentation here. And so we said that a multi-line comment in Python is enclosed between 3 pairs of double quotations, okay? And so basically with documentation, with Docstrings, you're gonna have basically an informative and descriptive explanation of what your function does. And then brief descriptions and lists for any parameters and return types, okay? So you're probably just gonna be returning 1 thing or 0 things, right? What if you just have a function that prints something? So you might not be returning anything and you might not have parameters, but this is an example of a function that has both inputs and an output, right? So it returns x minus y and it accepts 2 parameters. But we could look at an example of a function that only accepts parameters and doesn't return anything. So what if you say only print of A and B, okay? And then what it's going to do is we're going to say basically for t in range of A plus B, we're going to say print of t, okay? And so that's just going to print the values 0, 1, 2, 3, 4, 5, 6, 7, all the way up to A plus B minus 1. So you should go back to previous videos to learn about how the for loop works with the range command to basically iterate through values. So now how would you do documentation? How would you do docstrings for this method? So this function accepts 2 inputs, A and B, and and basically prints each value from 0 to a plus b minus 1 on a new line. Okay, that's basically what you would say for that. And then you would also need to have parameters. Okay, so this function doesn't return anything, but it has parameters. And so for these, I can't remember exactly what notation, so parameters, right? And then you would have a dash or something, and you could say a, you could say like a number, or you could say b, another number, right? And so these are not super specific, but this would sort of give you another example of what docstrings would look like. And now what we're going to do is we're going to hover over only print, and we're going to see what gets returned. Okay, so now you just have only print, and you see this description. Okay, and you see this description, and you can also see the parameters. Okay, so here it says param here. You can see the param and param. That means that a and b are the inputs to a function. So hopefully that's clear to you. Okay, and that's what's going on with that. Okay, and then you can also have, what if you wanted to have docstrings for a method that didn't have any inputs, a function that didn't have any inputs, but it only returns something? I think we did that just a few minutes ago. So with this h function, we could say this function returns 10. That would probably be your description, okay? And you would basically just say returns. What are the return values, right? And then you could basically say returns, and then you know, you would have to put whatever's returned before the closing quotes. So then you could basically say 10, you know, the value 10. Okay, and so that would basically tell you what's going on with that. So now you could go ahead and hover over the name of the function, just that little h right there, and then and you can see this function returns 10, and it tells you the returns value. So it says returns the value 10. So this is an example of a docstring, and for all your functions in your Python, if you go onto another software engineering company, you come up with a cool function that serves a cool purpose, but if other people are having a hard time understanding what the function does, then that will be frustrating. So this just provides a few more context clues. It helps the programmer make sense of the code so that you can say, oh, now I get why you said print of x times y, because your goal was to print the product of two numbers, right? So it's going back and forth between the human being interpretation and the computer interpretation. But anyway, you want to have these docstrings, and that's kind of how they're formatted. Okay. And I don't know how much more we can say about that, right? So you could just say, you know, so you need to remember that docstrings are formal multi-line comments that belong under a function header. Okay, so you need to specify what the function accepts, what it does, and what it returns. Okay, so this would basically be like the description. Okay, and then you need to specify parameters, so inputs that the function accepts when it is called. Okay, and you need to specify return values. So anything, any you know, number or string or list that would appear if you know, that would be returned. Okay, so that's all there is to say about it. Okay, so you need to specify those three things, and then if a function doesn't return something, like this only print function, you don't need to have a return section. If you have a function that returns something but doesn't have any parameters, like this function h, you only need to have a return section, not a parameter section. What we're going to talk about in this lesson, we're going to talk about something called modules. Okay, so we're going to learn about a new topic now. So modules are pieces of code that people have already written to accomplish tasks like generating random numbers and performing mathematical operations. Okay, so basically modules are pieces of code, right? I don't want to say the exact same thing twice, but basically it's code that has been written and shared by someone so that convenient functionality is accessible to everyone. Okay, this prevents us from needing to create functions that do relatively simple tasks. Okay, so it turns out that if you wanted to add up the elements in a list, we talked about different ways to do that. We said we could use a while loop, or we could use a for loop, right? But it turns out that there are actually built-in functions in Python that basically do that work. It basically already has that logic sort of built in and manifest already. And so then what we can do is just import that code into our Python programs, and then we'll already have that functionality available to us. So now that we've talked about writing our own functions, We can talk about modules, which is basically just inheriting or importing functions that someone else has already written for us. And this is kind of cool. It's nice to basically save yourself the work of creating a function, but still being able to use it, right? Being able to use its utility and not needing to figure out how to write it. So what we're going to do is we actually need to talk about a keyword in math or in Python. So what I'm going to do, I'm going to scroll all the way up to the top of my Python file, and you can see some residual code here from previous lessons when we were talking about this sample function thing. But what we're going to do is we're actually going to go over to Blackle. Okay, so I said in either lesson 0 or lesson 1 that this is a great search engine to use if you either care about the environment or you care about the numbers of penny that could be in your wallet and not forked over to the electric company every month. But now if you say math module Python, what I'm going to have you do is Google that. And basically in the Java videos, we started to look at documentation. So pretty frequently we were going to do Google and Blackle searches and to take a look at what types of functions and classes were provided by Java that we could then use. And really we found that that saved us a lot of work and made our programs a lot more interesting. The same kind of documentation is available with Python, and I would encourage you to Google things in Python. If you don't understand how to do something, or you want to basically have additional functionality or operation in your code, then you can go ahead and Google these things. So I'm going to have you go ahead and Google math module, okay? And you're going to click on the first one, and this is from docs.python.org, okay? So this is an official website, basically, that's produced and maintained by the people who are responsible for the programming language, okay? And so this is an example of a module, okay? So there are different modules, and so basically modules are classes that have functions in them, okay? And so we can basically implement or import new functions into our code without needing to write them from scratch, okay? And so this is an example of a module. There's so many types of modules, and I'm going to share other examples with you later in this video, but let's talk about math because we're going to try importing some of these functions and some of this functionality, okay? So what we're going to do is we're going to import this math module. And you can see some of the things that it does, right? So you can see we have a factorial function, so it can return x factorial, right? You have a floor function, which is the largest integer that's less than or equal to x, okay, for some input x. You have the greatest common denominator, the greatest common divisor of integers. You had something that will tell you whether or not a number is finite, okay, that's pretty simple. How about you have a permutation, you have a product or remainder. So you can see that this is basically a module that lets us do a lot of mathematical things. It allows us to go a little bit beyond adding and subtracting and just finding the modulus, the remainder. So this math.pow, what if you said math.pow of xy? Well, that would go ahead and raise x to the y and return that result. So how do we use this functionality? How do we get these functions into our code, right? Because what we could do is we could try calling one of these functions, right? We could say math.exp of 3, right? Because if we go on to this website, it seems to say that we can call math.exp of some number, and it'll give us e to that input, e to that number. But you can see there's an issue here. So it says, oh, I don't know what you mean by math. Well, maybe we shouldn't put math dot. What if we just called the exp function? Does Python know what that is? No. So it says, what's exp? What we're going to do is we're going to scroll up to the top of our Python file, and we're going to import a module. So what we're going to do is we're going to say import math. Okay, and so basically an import statement at the very top of our Python file allows us to import or implement new modules. So basically sets of functions, right? So basically import new modules, new sets of functions, new functionality, new operations, activities, however you want to think of it, new modules into our program that our file can then call on and use. Okay, so what we're going to do is we're going to say import math up here. Okay, and so now if you say math.exp of 3, it's not an issue. So now what did you do? So this import math is showing up on line 1. It's a special keyword in Python, okay? And so if you hover over it, you know, it gives you all kinds of description. We've been talking about Docstrings, right? And the documentation that shows up, and it gives you paragraphs and paragraphs about what import does. But the only thing you need to know is that it allows you to use these functions that we're seeing in the math class. These things are online, and someone wrote these functions. Someone figured out what lines of code they would need to write in order to get these things to do what they're expected to do. And there's cosine, trigonometric, hyperbolic, right? Hyperbolic sine, hyperbolic cosine, error function. You could have constants. You could have math.pi and math.e. But basically, we're going to say import math. And then now if we want to say math.exp of 3, then this will print e to the 3, right? So the value of the base of the natural logarithm multiplied by itself 3 times, okay? And then let's see, so the SQRT, I think I tried playing around with a erroneous line of code, so let's delete that, and then we're gonna run it. And indeed, it tells us that e cubed is about 20.08. And so if I went ahead and did a search for that, right, you could do e cubed, or e cubed, not e to the 8, but then you get 20.0855369. So it got all those digits right. And, you know, Python told us a little bit more than the GUI was able to tell us as far as decimal point precision goes. So that's kind of interesting. And then you can call other functions, right? So what if you wanted to call another function? What if you wanted the sine of an angle? You know, that sine of pi over 2 is 1, right? So how would you do sine of pi over 2? Well, what you can do is you can realize, I was scrolling here and you might have seen it a second ago, but there's actually constants. There's mathematical constants, and there are important constants in math. I think that 2 important ones are e and pi, okay? And then some people also want to say tau, and tau is just 2 pi, right? So I don't think that's way more interesting than pi itself. But let's say that we wanted to go ahead and figure out what the value of e is or something like that, right? So now what we could do is we could say math.e. And so this would be basically the representation of a constant. We're referring to this module. Basically, we basically print a module name and then dot, and then we can call either a function from it or a constant. If you're calling a function, you're going to have parentheses and then maybe some inputs to the function, like with exp. If you're just calling a constant, or sometimes called a field, this is just a constant. It's just a float. So it'll just be math.e. This is a number. Okay, so now you could go ahead and print math.e and you get the value of e. And odds are, if you do math.e times math.e times math.e, you would get the exact same thing as what was printed previously. So hopefully that makes sense to you. A couple other things to say. So I think we're just going to focus on the math module for this lesson, but I think in the next lesson, I'm going to spend just a little bit of time to show you one other module so we can spend 5 or 10 more minutes getting a little bit more practice. But what I want to tell you is that you can also choose to just import particular functions. So you can either import an entire module or use from math import square root to just import a particular function. So what if we didn't want to have access to all of the math functions? We only wanted to be able to use square root. So what we're going to do is, instead of writing just import math, we're going to say from the math module, from math, import square root. And so basically this would mean that the only function that's going to be available to us is the square root function. Okay, so hopefully that makes sense to you. And then if we go ahead and go down here, right, we can try something else. So now if you say math.square root of 10, it actually would have a problem with you saying math there, okay? Because what happened was you declared that the square root was already going to come from math. So basically Python actually has a problem if you're redundant here. So if you say from math, import square root. So if you're importing a particular function, then you just call that function name. So you would just say square root of 10. And that would be able to tell us the square root of 10, which is, you know, 3.162277766. That's kind of cool that those digits, you know, you get 2 digits at the same time with all those, but that's basically how it works. So you say, if you import math, then you would say print math.square root of 10, right? But if you say from math import square root, you would just say math.square root of 10. The last thing I'll say, this is kind of cool, but what you can do is we can actually take this one step further. Okay, so if we want to call math's square root function other than sqrt, write as, and then, you know, function name, you know, preferred function name after importing that function. So let me tell you what I mean by that. Up here we have from math import square root. What I'm going to do is I'm going to say as s. Okay, so I'm going to say from math import square root as s. This means that it's only going to import the square root function from the math class, but when I refer to it in my program, I'm going to be able to call it s, because I said I want you to refer to the square root function of the math module as s. So now instead of saying square root of 10, you would simply say s of 10, or we can do a different number to make it more interesting. But what's the square root of 81? It's 9.0, because the square root function of the math module is instructed to always return a float. Okay, so we're going to talk more about that in the next video. I think that's enough for now. So from UMills03, thanks for watching, and please subscribe.